Welcome to SPC Insights with Dr. Bill. This video takes a look at histograms and how to use them. A histogram looks at the history of your process. It tells you how often a range of values or a value occurred during a given time period. So in this video on histograms, we're going to begin by looking at patterns of process variation and how histogram shows you that pattern. We're going to talk about the 4 key questions a histogram answers for you, talk about the nomenclature associated with histograms, compare it to control charts, give a couple of examples, talk about how to construct a histogram, as well as how to interpret a histogram. Remember, a histogram is a picture of how your process stacks up over time, how often a value or range of values occur during a given time period. So let's talk about variation and patterns. Suppose you run a heat treating lab and you measure hardness on samples occasionally with a spec of 28 to 36. You take a sample, test it for hardness. Later on, you take another sample and test it for hardness. Do you get the same result? No, of course not. Things vary. But over time, what happens, you'll see the results begin to stack up into a pattern. And this pattern is called a histogram. It tells you how often a range of values occurred during a given time period. So, history of your process, that's what a histogram tells you. But it's going to tell you 4 things in particular. It's going to tell you the most frequent result, that's going to be the highest bar on the histogram. It's going to tell you the amount of variation which you can get from a standard deviation or how wide the histogram is. It's going to talk about the shape of the distribution. Is it normally distributed, bell-shaped, or is it skewed? And it's going to talk about the relationship to specifications. Is everything within spec or do we have some out of spec? So let's talk a little bit about the nomenclature that comes. When you see a histogram, it has bars on it, and those bars are called class. And this one has 10 different classes on it. And the highest class is called the mode, the one that occurs most frequently. And then also we have the class width, is how wide is each of these bars. In this example, each one is 1 Rockwell hardness width. So a histogram is going to tell you 4 things. It's going to tell you the most frequently occurring value, or range of values. It's going to tell you the shape of the variation, like this one, it looks pretty normal. It's going to tell you the relationship to specifications, and we do have a few things beyond the specifications. And it's going to tell you the amount of variation from the maximum to the minimum value that's there. But a histogram is not a control chart. There are differences. Remember, with a control chart, you're plotting data over time. And after a while, you calculate an average and control limits. And as long as everything's within those limits and there are no patterns, we say that you have just common causes and the processor is in control. You can't have out of control things like points beyond the control limits. So a control chart tells you if your process is in or out of control. A histogram does not do that, but it gives you additional information. So it's not a replacement for control charts. What happens with histograms is you lose the time orderedness of the data. But you want to use one in addition to control charts because it will help tell you some things about your process. So when do you want to use a histogram? Well, you're going to use a histogram when you have numeric data, things that you can count. And then when you want to see the shape or distribution of the process, you're going to use a histogram. And also, you're going to use it to analyze if a process meets customer specifications. It's part of the process capability analysis. Here is a typical histogram example. You have most of the points near the middle, and as you go out away from the average or the middle, they get fewer and fewer, and it looks like a bell-shaped curve. So this is typical of what you have. And here's a histogram that kind of shows a problem because it doesn't have things much above 69, the upper spec limit. So it would appear that they are not recording out of spec results if this was a normal distribution like the one we just looked at. You can also see a problem if a histogram has 2 peaks. It's called a bimodal distribution. That means your process has at least 2 processes, 2 shifts, night and day. And what's happening is that's increasing the variation in your process. If you can combine them into one, bring them together, you'll reduce variation. But a histogram then also says how you're doing versus specs. And here's an example of using blood pressure where we're doing the systolic blood pressure. If it's less than 120, that's normal. Stage 1 hypertension is less than 160, and stage 2 hypertension is greater than 160. So what's this histogram tell us about this blood pressure? Well, most of it is less than 140, which is the pre-hypertension stage, and a lot of it is less than 120. There are skewed distributions too. Data doesn't always follow a normal distribution. Here's a histogram of the time to answer inbound calls to a call center. Okay, this is a naturally occurring Histogram. This one is called positively skewed since the long tail is on the positive side of the peak. It's also said skewed to the right because the long tail is on the right-hand side of the peak. So you can have them skewed that way, but you can also have them skewed the other way, as we see here. Here's a histogram of the age of people when they pass away. And you can see it's negatively skewed, is what we would say in this case, because the long tail is on the negative side of the peak, or it is skewed to the left because the long tail is on the left side of the peak, left-hand side of the peak. So skewed distributions are natural. So what are the steps in constructing a histogram? Well, this is the manual method of doing it. We're going to show how to do it in SPC for Excel software in just a second. But you select the time frame, gather at least 50 data points. You select the number of classes you have, how many bars you have. That's based on the number of points. Calculate the overall range as the maximum minus the minimum. Then you calculate the class width by taking that range and dividing by your number of classes. You're going to round H to a convenient number. And you want to select the boundaries so the data doesn't fall on the boundary between two classes, and you have to decide which one it goes to. Record the number of data points in each class, construct the histogram, and then you label the histogram and include any other important information such as the time period. But we don't do that anymore because now we're going to use software to do it. Here's the SPC for Excel software. We've entered the information into an Excel spreadsheet. You come in and you name the histogram. We're going to just simply call it histogram, and then we're going to have a couple options here. We're going to add specifications to our process so you can see what that looks. 30 is the lower spec, 70 is the upper. We're going to add a normal distribution, select OK, and you have your histogram done automatically for you along with the descriptive statistics. So the key thing though, remember about a histogram is it tells you four main things: the most frequently occurring value, the shape of the distribution, the relationship to specs, as well as the amount of variation that exists in the process. So those four key questions are what a histogram answers for you: most frequently occurring value, shape, relationship to specs, and the amount of variation. So in this histogram video, we took a look at patterns of variation. We answered the four key questions that a histogram will answer for you. We talked about nomenclature, when to use them, some examples, talked about skewed distributions, how to construct them, and then of course, how to interpret them. Thank you for watching our video. For more SPC insights, hit the subscribe button. You can visit our SPC knowledge base online, over 200 publications on SPC and statistical analysis topics, all free. Or you can buy our software or try it, a demo for free, and make your own histograms. www.spcforexcel.com. And once again, thank you very much for watching the video.